Okay, in today's lesson, we're going to look at rational expressions. So just a review of the different types of number sets. The set of natural numbers is all the whole numbers starting with 1. So 1, 2, 3, and 4. Once they discovered the concept of 0, now we have the whole number set. So the whole number set is the natural number set including 0. And then they understood the concept of negative values. So now we have the set of integers. And then real numbers is all integers, decimals, and fractions. So now we are going to look at rational numbers. So rational numbers can be written as a over b. And just noting that the denominator cannot be 0. So these are all going to look like fractions. So irrational numbers are numbers that cannot be written as a rational number. We don't really need to worry about irrational numbers. So rational expressions are quotients where the numerator and the denominator are going to be polynomials. So keeping in mind that the denominator cannot equal 0, we are always asked to state the restrictions on the denominator when we do this type of question. So all we have to look at is the denominator, not the numerator, and 2xy cannot be 0. So that means x could not be 0 because 2 times 0 would be 0 and y could not be 0. In this denominator, we have x minus 1. So if we set x minus 1 not equal to 0 and then solve for x, then x cannot equal 1 because 1 minus 1 would give us 0. In this question, we have two denominators. So 2x plus 1 cannot be 0, 2x cannot be negative 1, and x cannot be negative 1/2. So that's one restriction. And we would also have x minus 4 cannot be 0, x cannot be 4. So that question has two restrictions. So with rational expressions, when you are simplifying, you always state the restrictions. Even if it doesn't ask you to, you should always state them. Okay, so when we're just simplifying one term, rational expressions, the first thing we want to make sure is that everything is factored. One thing you cannot do is something like that. You cannot reduce terms that are added or subtracted. That is a big no-no. Cannot reduce terms that are added or subtracted. It has to be factored. You can only reduce terms that are multiplied. So that means we need to factor. Okay. So we're going to factor the numerator. So I see there's a common 5a, so I'll take that out. So this is where our factoring skills come in. Once I have factored, now I can reduce. So 5a and 5a can be reduced. And we are left with 4a squared minus 7a plus 1. So that is just factoring the numerator and then reducing. Likewise, in this question, we're going to see what we can factor. So in the numerator, I see a common 4m. In the denominator, I see a common 8. So what can we reduce now? Well, we can reduce the m minus 6, and we can reduce the 4, goes into 8 twice. So final result is m over 2. Now remember, we said we have to state restrictions. So in the first example, 5a cannot be 0, so therefore a cannot be 0. So there's my restriction. And then in this question, it's much easier to state restrictions when it's factored. The 8 is not a restriction, it's just a constant number, but m minus 6, oops. M minus 6 cannot be 0, so therefore m cannot be 6. So this is my restriction that I always state every time I do a rational expression. Okay, so let's look at a couple more. So it says simplify and state any restrictions. I'm going to factor the numerator. I see a common 10. In the bottom, I see a common 5. And we can reduce. So n minus 3 reduces. 10 reduces by 5 to 2. The restriction is n minus 3 cannot be 0, therefore n cannot be 3. Okay, in this question we have a common 4 in the numerator. In the bottom we now have a trinomial, so we need to factor that. It's a simple one. So we just need two numbers that multiply to get 20 and add to get 9, which would be 5 and 4. Now I can reduce. And it's always good at this step to state your restrictions. So x cannot equal -5 and x cannot equal -4. Those are my restrictions. And then my final simplified answer is 4 over x plus 4. In this question, in the numerator, we have two terms. They're both squares and it's subtraction, so that is a difference of squares. So I can factor that. The bottom is already factored. And we will reduce. And we are left with a minus 1 in the numerator, a plus 3 in the denominator. I'll state my restrictions. A cannot equal -1 and a cannot equal -3. So these are some practice questions that you can try. And the answers are down below. I don't think there's anything here. Just keep in mind in this one, 5 minus x is not the same as x minus 5, so just be careful with that. Well, let's do that one. We'll factor that one, because these are the ones we want to watch for. So I'm going to, the numerator is already factored, so we'll leave that. In the bottom, it's a simple trinomial, so we need two numbers that multiply to get 110 and add to get 17. So let's see, 110. So 5 and 22. So it has to be positive 17, so we'll have positive 22 minus 5. So that adds to 17 and multiplies to -110. Now, one thing to be careful of is 5 minus x is not the same as x minus 5. You can factor out a negative sign if you want to reverse the terms in that binomial. So I could take 5 minus x, factor out a negative to make it x minus 5. Let's put it at the front. That way we know where it came from. So I'm going to take the 5 minus x and make it negative x minus 5. On the bottom we have these two terms, and now I can reduce because x minus 5 is the same as x minus 5. And so we'll be left with the negative x plus 2 over x plus 22. And so you'll see at the bottom here, you'll see that's why that negative is there. And then the restrictions is x cannot equal -22 and x cannot equal 5.